Hi everyone, today I'm going to discuss equation of a circle, and we will be working on equation of a circle using the different forms of equation of a circle. So on the right side, you see circle C with center at HK, and then you also have scene or you see a triangle, a right triangle particularly with vertices point P at XY, point A, and point C at HK. Now, using the distance formula, we're going to derive a formula for the equation of the circle by working on R here. So as you can see, this is a right triangle. So we can solve for the distance of R here, which is also the radius of circle C using the distance formula. So we have R equals square root on the square of the x coordinates x minus h squared plus the square on the difference between the y coordinates y minus k. By squaring both sides of the equation, we have r squared equals quantity x minus h squared plus quantity y minus k squared. So in this manner, the radical symbol on the right side was eliminated, and interchanging the position of the two, we get the equation of the circle in center radius form or in standard form, where the center is at hk and r here is the radius of the circle. So if the equation of the circle is expressed in center radius form, by inspection, we can easily identify the center, and we can easily identify the length of the radius by working on the square root of r squared, which is r. Now, the illustration that you see is a unit circle, and we will be using the unit circle as we go along with our next lesson in trigonometry. And the unit circle is centered at the origin, meaning the center is at 0, 0, and the radius has a length equal to 1 unit. Now, the question here is, what is its center radius form of equation? So by substituting the given in the formula, which is this one, since h and k equals 0, so we have x squared plus y squared, and then r is 1, 1 squared is 1. So this is now the formula for any unit circle. X squared plus y squared equals 1. So this time we're asked to identify the coordinates of the center of the circle and find the equation represented by the circle. Now, by inspection class, this is the center of the circle with coordinates at -3, +3. So take note that the center is located at -3, 3. And then we have to find another point, any point on the circle, to solve for the radius and then come up with the equation of that circle. So if we're going to consider the point here and we assign this as point P, so point P has coordinates, or point P is at 3, 3. So we can make use of this point together with the coordinates of the center to solve for r using the distance formula. So this is like 3 minus -3. So we have 3 plus 3 quantity squared plus 3 minus 3 quantity squared. So we know that this is 0 and 3 plus 3 is 6. So the square of 6 is 36. So we have to get the square root, which is equal to 6 units. Since we have the center, we have the length of the radius. Now, the equation of that circle is represented by quantity. So we have to substitute the given in this form. So we have quantity x plus 3 squared plus quantity y minus 3 squared equals the square of 6, which is 36. So this is now the equation of the circle. This time we have the general form. So the general form can be derived from the center radius form. So remember again that this is the center radius form, x minus h quantity squared plus y minus k quantity squared equals r squared. By expanding the binomial from the left side and then transposing r squared on the left side and equate everything to 0, will come up with the general form. So using square of binomial, so this is x squared minus 2hk plus h squared for this. And then expanding this binomial, we have y squared minus 2yk plus k squared minus r squared equals 0. Now, this minus 2h here, class, is the coefficient of, this has to be x, rather. This must be x. And this minus 2h is the coefficient of x here. And then this minus 2k here is the coefficient of y, which is d. So this is minus 2yk. So k and negative 2 are actually the coefficients of y, which is our d. And as we combine h squared, k squared, and negative r squared, so they can be combined since they are constant terms and they are represented by e. So that's how we obtain the general form from the center radius form. So let's try to work on each item here involving equation of a circle. So in number 1, we're asked to find the center and the radius of the circle defined by this equation. So what we're going to do is to transpose the constant term on the other side and form two groups such that the same variables will be grouped together. So we have here x squared plus 10x, and then the other group is y squared minus 2y, and then transpose negative 6 on the other side, we have 6. Now we have to think of an expression such that when added to each group, the group will be a perfect square trinomial, and that can be done using completing the square. So for the first group, we just have to divide the coefficient of x here by 2, and then we square. So that's 5 squared. And then for the second group, we'll divide negative 2 by 1. So that's negative 1, and then we squared again. So we have x squared plus 10x plus 25. And then the other group is y squared minus 2y plus 1. Now, class, whatever value we added on the left side, it has to be done on the other side to retain its equality. So we have 6 plus 25 plus 1. Now, the next thing that we're going to do is to factor each perfect square trinomial here. So we have, so how do we do that? We extract the square root of the first term plus the square root of 25. So that's 5 quantity squared. Here we extract the square root of y squared. Then copy the sign of the middle term, square root of 1 quantity squared. And then this is 6 plus 25 plus 1, we get 32. Now here, we have to consider, so by inspection, the coordinates of the center is at negative 5, 1. And by extracting the square root of 32 here, because r squared equals 32, so we get we get r equals square root of 32. So we know that 32 has a perfect square factor, and this is equal to 16 times 2. So therefore, r equals 4 square root of 2. For number 2, we have this one. And we have to write this first into its center radius form. So we have x plus 1 quantity squared plus y plus 2 quantity squared equals 4 squared, and that's 16. And then expand the binomial. So by square of binomial, we have x squared plus 2x plus 1. And then we have y squared plus 4y plus 4. And then transpose negative 16 on the other side. So we have 16. Then combine like terms. So we have x squared plus y squared, and arrange in this manner. Plus we have 2x plus 4y, and then combine like terms. 1 plus 4 is 5 minus 16. So we have minus 11 equals 0. So this is the equation now. And then for the last expression, same with what we did in number 1, we have to group the left side. So we have x squared plus 4x. And then we have y squared minus 6y. Transpose negative 3 on the other side. Now think of an expression such that when added to each group, here will be a perfect square trinomial. So we will divide the coefficient of x by 2 and then square. For negative 6, we'll divide it by 2 and then we square. So we have x squared plus 4x plus 4. And then we have y squared minus 6y plus 9. And then whatever we added on the left side, it has to be done on the other side. So we have plus 4 and then plus 9. So the last thing that we're going to do is to factor each perfect square trinomial. And that is done by extracting the square root of the first term, copy the sign of the middle term, and then extract the square root of the last term, quantity squared. Same with the other group, square root of y squared, and then copy the middle term, the sign, and then square root of 9, quantity squared, and then this is 16. So by inspection, the center is located at negative 2, 3, with radius equals 4 units. Because r squared equals 16, so extracting the square root, we get r equals 4. Now, that's how we work on the equation of the circle using the center radius form and the general form. Now, what I want you to do is to summarize the lesson in a statement or two by simply comparing the center radius form or the general form, or just summarize the lesson as how it was presented. So goodbye for now.